Yes. Okay, so I've got a lot of questions on the homework. So I thought I'm just going to have this separate session so that questions that you have, I could go over with you or give you guidance or whatnot. And so I've talked to several people already. So, you know, I can just go down the list and see what questions you have. Does anybody want to, let me put it this way. Does anybody want to start off with a question? All right, Emma, you're not shy. I know you can start off with a question.
Did you figure out number 12?
Which one was number 12?
It was the one that you said that
Was it
you
the
would.
P? Was it the P and the C?
Yeah.
Yep. Yes, I did. I'm going to make it easier because that was a mess that we looked at earlier. All right, let me get it here. I've already got it worked out. There. Oh, that was 25 actually. Was the P and the C? Which one? Let me pull it up, guys. I'm going to do a screen share so I can pull this up and you guys can see it. Okay. So here's number 12. Oh, okay. Yeah. I had it down to something else. Okay, yeah. Let me show you how I did this problem and to be the easier way to do it. So bear with me 1 second. I'm going to swap back over now. Like several people had the same question. So I'm going to now share a different screen. Ooh, oops, I turned that on. There we go. Yeah, let's try that again. Okay. Can you guys all see this? Yes?
Yes.
Thank you. Everybody's quiet. It's like nobody's speaking. Okay, so obviously you may have different numbers here than what I have. But you had a P equals this function and a C equals this function. You're looking for dP dt. Okay, well, obviously, if you do the derivative of P, you're getting dP dC, and this is dC dt. And there's several ways to approach it. The way I started off with became cumbersome, so I said, let me work this out differently, and I'll get back with you on it. So it's basically doing the chain rule. All right. And oh, we wanted to know at T equals 3, at least that was in the problem that I had here. Using this is going to make it easier if we put this in after we differentiate, but before we put it all together. Okay, so C prime is dC dt. Okay, so again, this is, think of a composition of functions that we're doing here. All right, well, the derivative of this would be negative 7t to the negative 2. Okay. Now at t equals 3, that gives me an actual value to work with, negative 7 over 9. Okay. So I'm going to start with that. Now that I have c prime, which is dc dt, all right, then I'm going to come in here and I'm going to find dp dt. I'm going to do the p function implicitly with respect to time. All right. So the p function, the derivative would be dp dt, okay, equals 5c, well, that's 5 dc dt. All right, derivative of negative 18c to the negative 1 is 18c to the negative 2 dc dt, right? Well, I know what dc dt is because I went ahead and evaluated my derivative at t equals 3. It was negative 7 over 9. And so that's what I'm going to put in here, and I'm going to put that in here. Okay, but now I have this extra c here. So you need to know, well, what is c? Well, if you take t equals 3 and you plug it into your c function, you have a value for c. C equals 9 plus 7/3, which is 34/3. So I'm just plugging that in right here.
I have a question. Why is it 8 on the DP over DP? Like, why are we using 8?
Why are we using, oh, I just didn't write down the number here. It's,
Okay.
yeah, that's what it is. It's actually, it's not 8, it's 18. It's just an oversight, which means this number is going to be a little bit off. Let me rerun my number here. Let's see here. So it's going to be, let me put it back in. Negative insert, that's going to be 18 times 7. And all that is divided by 1156. There you go. Negative 3.997, and so forth. Okay, yeah, I was just oversight me not putting in the 1 in front of the 8. Cool. Okay, guys, any other questions on that problem? All good?
Yeah, why do you multiply the -7 over 9 by the 5 if the derivative like you, oh wait, never mind.
You see it?
Yep.
Okay.
Wait, where did you get 34 over 3?
34 over 3. I needed a value for C. When you differentiate, when you find dp dt, you'll end up here with 18c to the -2 times dc dt. In order to get a numeric value, I need to know what C is. Well, C is up here. C is 9 plus 7t to the -1. Just plug in 3 there. That's 9 plus 7 over t. That's 9 plus 7/3. Common denominator, it's 21/3. Okay. And that would give that to you. 27/3, my bad, 27/3. And that would give you 34/3. Does that make sense? I don't see anybody talking. So I'm gonna hope that makes sense.
Yeah. Sorry, I was on mute.
Oh, okay, that's okay. And now I got a lot of people on the call. And if you join, just FYI, I am recording this call or this Zoom meeting so that I can post it to Canvas for those who couldn't make it. And it's good to see people's actual faces without masks. See, I don't know anybody because I'm not used to seeing you without your masks. Except for Emma, I'm used to seeing you. And Sydney.
Could you go over number 15?
15, sure. Let's look at number 15. Let me do another screen share first. Let's see what it is. Oh, where's my screen share? Oops. Share screen. Okay. Yes. Yeah. This is not a fun problem. This is an exercise in, I don't know, exhaustion personally. But yeah, let me show you. In fact, I brought up something. I'm going to show you how to work out this problem, how they have this thing worked out. This is how they want their answer, by the way, in this format. I simplified this ahead of time, but I don't think it's going to take that one. You know how picky this system can be. So let me show you something real quick. No, not that. Okay. I'm going to give you another. I'm going to give you an example. We'll talk through how to do this, and so you can write down and get and see if it makes sense to you. Let me change my sharing. Okay. In this particular example, we have y over x plus x over y equals 2y. Obviously, if you have a coefficient, well, you can deal with the coefficient. It works the same. Okay, so basically you're doing two quotient rules here. So d times n prime, so that's x times y prime plus y times x prime. Sorry, my bad, I said that backwards. D times n prime, so that's x times y prime minus y times x prime, which of course the derivative of x in this case would be 1 all over x squared, and then repeat the process here. D, which is y, times n prime, the derivative of x, of course, is 1. Prime here means dy dx, of course. Okay, minus your n times your d prime, which is 1 dy dx all over x squared. This equals to y, which would be 2y prime. Are you guys all good with just this part right here?
Yeah.
Hopefully good. All right. And now, if you notice here, what we can do is we can split this thing apart. We can move over. Okay, so what we did here, we have our y squared. We could bring this, we could separate this out. Let's see how they did this. Okay, because we have a common denominator here, they went ahead and split this thing apart. So this would be the same as x over x squared. Okay, let's see here. No, it'd be xy prime over x squared. That's going to give you y prime over x. Let's see, where's your y prime? There's your y prime over. They skipped some steps here. And then it's going to be your y over x squared, which is over here. And we'll do the same thing over here, y over y squared. That's going to be 1 over y, which is over here. And then we have our minus y, pardon me, xy prime all over y squared. And that got moved over here. Basically, the goal is to get every single thing here with a y prime moved to one side, everything else on the other side. Okay, and so when you do that, then we can get our common denominator here and solve this out. That's not a pretty problem. I'm going to tell you that I think it's safe to say that for the exam, you're not going to see a problem like this that's this complicated. All right, does that make sense, or do you want me to actually work it out for you? Maybe it makes sense. Hopefully that's good. I don't hear anybody.
Can we work this one out? I've done it a couple times and I'm like not getting the final correct one.
Sure, sure. Let me get a piece of paper here. And I'm going to do is change over to share this other screen. And we'll work it out. I'm going to let me write down my problem here. Y over x plus x over y equals 2y. Okay, now new share. Okay, I gotta move that again. Okay, so can you all see what I wrote out here? Can y'all see that? Okay,
Yeah.
cool. Okay, thank you. Okay, so first thing you want to do is we're going to differentiate all of this. Okay, so it's going to be d, which is your x times derivative of y, which is 1 y prime. I'm gonna leave this. I don't usually do this because I really don't like to do the y prime because you could get really confused. But because we're dealing with fractions, I don't want to dy dx within a fraction within a fraction. I think that makes it harder to understand. So I'm going to leave it in terms of this. D times n prime minus n numerator y times d prime, which of course that is just 1 all over d squared. That's x squared. Now repeat the process here. All right, d, which is y. Okay, d times n prime, well, that's just 1 minus n numerator x times d prime, well, that's 1 prime, that's y prime, all over y squared equals, all right, 2y, that's 2, it's a y, so y prime. It just makes it easier when you're dealing with fractions to split it up that way. Okay, and now next thing we're going to do is we're going to split this thing apart, you know, because we have these common denominators here. All right, we have all of this minus this. We have this minus all of this. Okay, so that's going to be xy prime over x squared minus y over x squared, right? Do y'all agree with that? Okay. Let me know if you can't see this at any point because I'm not really sure if you can or not. Okay, plus, repeat the process. This is going to be y over y squared minus xy prime all over y squared equals, of course, 2y prime. Okay, well, this x, get a different color. Let's see. That x goes away, that power goes away. That y goes away, that power goes away. Let's see, that's a prime. I can't do anything with that or with that. So this becomes y prime over x minus y over x squared plus 1 over y minus xy prime over y squared equals 2y prime. Okay, at this point, get your primes on one side. Get everything else on the other side. Okay, so I'm going to leave that guy here, y prime over x. I'm going to leave this guy here, minus xy prime over y squared equals, no, I got to move that guy over. That's a y prime. Minus 2y prime equals, I'm going to move this guy over by adding him, y over x squared, subtract this guy over, okay, minus 1 over y. Okay, so far so good? Hopefully. Hopefully so far so good. All right, so it's the next step. Let's factor out our y primes. It's all on the top of these 3 terms here. So that gives me y prime times what's left. Well, that would be 1 over x minus x over y squared minus 2. Okay, equals this guy right here, y over x squared minus 1 over y. Okay, does that make sense? Now let's get a common denominator because we need to divide to isolate y prime. Your common denominator here is xy squared. Okay, so you would do y squared top and bottom here. You're going to do x top and bottom here. You're going to do xy squared here. You get the idea. I hopefully get the idea. In any case, what this would end up giving you is y prime times, let's see here, y squared minus x squared minus 2xy all over the common denominator of xy squared equals y squared minus x squared all over the common denominator of xy squared. And that would imply Okay, if you were to isolate y prime, make sure you can see that. Yeah, you can see it. Okay, cool. So if you were to isolate y prime, it has a fraction coefficient. So multiply by the reciprocal of the fraction. All right, which means my final answer, because I'm about to run space, is y prime equals, I'm going to put it down here. So that's going to be y squared minus x squared all over x y squared times the reciprocal of this guy. Oh, look what happens to my xy squared. So that's convenient. Those cancel. So y prime is this binomial over this trinomial. Let's get it where you can see it all there. Okay. Seth, did that help? Good.
When you
Yes, it did. Thank you.
when you were making a common denominator for the 2xy, why
Uh-huh.
is it 2x? I'm sorry, for the 2. Why is it 2xy instead of 2xy
Oh,
squared?
it's not. It's not. It is. It should be 2xy squared. Again, oversight. Prone to oversights. It's easy to do.
And then you just factored out the common
Once I
denominator.
did that, I did this in order to make this one fraction. Because
Mhm.
once I have one fraction, then I can multiply both sides by the reciprocal to isolate my y prime.
Oh, you multiply. Okay, I see. I see. I
Yep.
see. Okay.
So
So
since we
why
have
didn't
variables like in the R problems, like we would just like use that formula with the variables.
Say it again.
Or since we have numbers, like we have like I have like
Oh, yeah.
2y over
It's just
x.
it's just a coefficient. Coefficients never go away. Okay, they can be reduced, but no, they never go away. Just like with the 2y at the top became 2y prime, you would just keep it there and multiply it.
Okay.
It would work the same way.
So why is the answer on achieve? Why do they multiply the top and the bottom by, or they multiply the whole numerator by y and then the whole denominator by x, like afterwards? Why do they do
Well,
that?
what they did is they factored it out.
Well, it's the same thing.
Yeah, I don't know why they have it in that way, quite frankly. And I don't think they should discount your answer if you didn't factor it out and write it in that format. But I'd be very interested to know if they did. Let me know if they do, because I don't see why that would be the case. It would not make any sense. Okay. In the interest of time, I mean, hopefully this makes sense to you. Does this help, by the way?
Yes, very much. Thank you.
Good. Glad of that. So, what other questions while we still are all together here on the call?
Could you 25?
Which one? 25? Yeah, I could do 25. I figured I might hear about 25. Let me do a new screen share. Okay, come on. Cut that out. See if I can get to a new screen share. Oh, goodness. Let's see here. Here we go. Okay, 25. Oh, yeah, we were talking about this one earlier today. All right, I have that one already worked out from talking about it earlier today. So let me get it and I'm going to show it to you. And that way I can just talk through it without recreating it. Messy. Okay, yeah, my handwriting is kind of messy. And My problem again is going to look a little bit different from yours, but you'll get the idea of the process. Let's see. Screen share, share. Okay. Hopefully you guys can all see this here. Okay, so here was the problem that I had when it brought up. And you're looking for the points at which the tangent line is horizontal, correct? Okay, good. All right, so obviously it's implicit. All right, you're going to find dy dx. So we have 6x here, dx dx. This is going to be 8y dy dx. This is a product rule. First, second. First time second prime, second time first prime equals 0. Obviously, your goal here is to isolate dy dx, so you know how to do that. And then you would have this guy as dy dx. Well, where the tangent line is horizontal, this gives you the formula for the tangent slope anywhere. We want it to be horizontal. That means the slope has to be 0. Set this equal to 0. Here's the trick to this problem, okay? Well, for any fraction to be 0, it means the top has to be 0. 0 over any non-zero is in itself 0, right? So just set the top equal to 0. Well, now you've got a relationship between two variables here. All right, I solved for y, added the 6x over, which means y equals negative 2x. This is the key here. Now you got this variable, sorry, you've got this variable here, and so you need a numeric value though. All right, so how do we get that? Well, you take this, because this is the relationship between the two, and you plug that into the original equation. Here is your original equation. In other words, what we're trying to do is to get this down to one variable so that we can solve it. Okay, so if y equals 2x, everywhere there's a y, replace it with 2x. So 3x squared plus 4 times y squared, that's 4 times negative 2x squared, plus 3xy, 3 times negative 2x times x equals 36. Okay, this is going to allow us to get our value for x. So luckily, everything is an x, so combine them all. In this particular case, with these numbers, I got positive 13x squared equals 36. X squared, okay, it would be 36 over 13. You square root it. Don't forget, when you square root it, you have a plus or minus. Earlier, I had an issue reading my handwriting because my handwriting is awful. So I have to rewrite this. Is plus or minus root 36 over 13. I could simplify that. Square root of 36 is 6, plus or minus 6 over root 13, which of course is, again, let me put this in and simplify it. That is going to be plus or minus 6 square root of 13 over 13. Those are your two x values. So you're going to have two ordered pairs, positive 6 root 13 over 13 and negative 6 root 13 over 13. Now, instead of plugging this back into the original equation and coming up with a monumental mess, I don't recommend doing that. What I recommend doing is using your relationship between your x and your y. Remember, this is the relationship that we got, and then we showed that it was the same, it holds true up here. So just using this. If y equals negative 2 times x, and x is, say, positive 6 root 13 over 13, well, negative 2 times that would be negative 12 root 13 over 13. So one of your ordered pairs would be 6 root 13 over 13, negative 12 root 13 over 13. You get the idea, guys? Okay. So, and you're going to do the same thing with the negative because you have two of them here. Let me rewrite this to where it looks better. And it began to run out of space here. So my ordered pairs would be positive 6 square root of 13 over 13, comma, and again, if my y value is negative twice the x, that's going to be negative 2 times x is 12, square root of 13 over 13. Okay, and then my second ordered pair, basically it's the very same numbers, just opposite signs. So negative 6 root 13 over 13, comma, now positive 12 root 13 over 13. There you go. Those are your answers to that. Okay, make sense, guys? Anybody have any questions on it? I beg your pardon?
Could you do 24 after?
I could do 24. In fact, I already have that one worked out as well, if I'm not mistaken. But does anybody have any questions on this before I go on to the next one? And again, like I said, this is being recorded, so I'll post it and you can go back and rewatch it. Okay, let's see. Let me go back over here. And 24. Yeah, and it looks like these numbers are going to be awful. And it's kind of surprising that they worked out so nicely, but they did. Let me get this for you. Show this to you. This was actually rather surprising. This worked out so well. Oh, excuse me, guys. Oh, goodness. Okay. Now this was, I'll show you the ordered pair was what? My ordered pair was different. It was 749. Okay. So your ordered pair is what's going to be different. Let me go back to a different screen share now. Okay. Again, I apologize, my writing is not very good. Here's the original problem. Okay, the point that I was given was 7,49. Most likely, I suspect for this to work out, for all y'all, you probably have basically a number and then its square would be its y value. Okay, so this is, oh, excuse me, I'm tired. Implicit again. So it's an e term. Remember, to differentiate e, you rewrite the original problem and then times it by the derivative of the power. Derivative of x squared is 2x, and that would be dx dx, which is 1, minus derivative of y is 1. It's a y, dy dx. So you have a binomial here. Equals, this is your quotient rule. So just your quotient rule going on here. There's a x squared times 1 dy dx over y squared. Okay. And your next step, excuse me, I don't mean to be yawning at you. We need to isolate our dy dx. And so here he's stuck in a binomial. Distribute the e term to both of those. 2x times e raised to this power minus e raised to this power dy dx equals, all right, and I did this like that first one. We split it apart. We have all of this over y squared minus all of this over y squared. We can simplify it down that way. Okay, so that's 2xy over y squared. That y went away, the square goes away. X squared over y squared dy dx. So now doing that, I've gotten all my parentheses gone. Okay, and I could get my dy dx's on one side, everything else on the other side, which is what I did right here. That's just adding and subtracting terms to move it around. Okay. And then got my non-dy dx terms on the right side. Now factor out your dy dx. Okay, now you notice we have fractions within fractions. Don't like that. Make it easier on yourselves. So one is a y, one is a y squared. If I multiply top and bottom here by y squared, I can distribute this out and cancel out those guys. There's a y squared here. There's a single y here because that one canceled. There's a y squared here, that one goes away. Okay, so this is dy dx. Looks awful. I bet you would agree with that. Looks terrible. But it actually works out pretty well. When you put in these numbers, if 7 in this case is your x and 49 is your y, just everywhere there's an x, put in 7. Where there's a y, put in 49. I ran out of room here, so I'm going to go on to the next page. So when you do all of that, all right, this is what you would get. Again, I'm kind of surprised this worked out so nicely, but it did conveniently because these e's go away. Why do they go away? Because it's e to the now 0 power. Nicely. And then for this, guys, just let your calculator work its magic on that. And it actually works out to a whole number. And I didn't even finish out the problem at this point because here I have m is 14, I have x is 7, y is 49, y equal mx plus b. Just plug it in. Questions, guys?
Can you go back to the other page, please?
Sure, you bet.
Okay.
Let me zoom it out so you can see the whole thing. Here we go. Anything there anybody want me to explain? Okay. I'll do one more call for problem and then I'll have to go ahead and get off the call. Was there anything else y'all wanted me to look at?
Sorry for asking again, but can you do number 8?
Number 8?
Yeah.
All right, let's look at, go back over here. Okay, yeah, that one's not too terribly bad. All right, so in fact, I did one very similar to it. Let's see if I have that and save time as well. I think I did that same problem, just with a different number. Okay, now let me show you one. That one involves knowing a trig identity. One of the ones I said you needed to know. I'm kind of glad you asked about that problem. All right, I'm going to swap back over. And then we'll go through that one, and that'll be the last one here. Okay, cool. Now the problem that I worked out earlier, it's just different numbers, same basic problem. Looking for the derivative with respect to x of 3 times the square root of sine 4x cos 4x. Okay. Here's what you need to know. Now you could make this into a chain rule with an embedded product rule, and it'll be kind of nasty. It'll be a mess. There's a much easier way to go about this problem. I'm going to show you the easy way to go about it. It's just simply knowing one of your trig identities. All right, and that is this identity over here. It is from your, hopefully, memory or from your formula chart, sine of 2x equal to sine x cos x. You guys remember that? Hopefully. Okay, anyway, it's one of the ones I said you should know. It's one of the double angle formulas. Well, let's compare it to this. This is sine 4x cos 4x. The coefficient of this is 1. This is 2. So I need for this to have a 1 in front of it, not a 2. So it's an equation. I'm just going to divide both sides by 2, or basically multiply by a half. That gives me 1/2 sine of 2x equals sine x cos x. In other words, I'm looking for a way to make this mimic this so I can make this a much easier problem. Okay. Now, in the formula, okay, whatever my value, my sine and my cosine, whatever the coefficient is of this, I would double it to get its equivalent as a single sine term. Okay, so if this is a 1, I would double it to become a 2. Okay, so if this is a 4, I double it to become a what? Well, I hope you said 4 doubled is 8. Okay, so that would be 1/2 of double this. This would be times sine of 8x equals sine 4x cos 4x. Okay, hopefully you guys see the relationship there. Because again, your rule is in your product here, the angle has a coefficient of 1. Your single sine has a coefficient of 2. So whatever this is over here, double it to get this. Well, if this is a 4, double it to get this. You good with that, guys? I think everybody is off of the video. A few people, so I don't see anybody's face. Everybody has stopped the video.
We
Oh,
can see your screen.
okay, well, that's good. I'm just not getting any feedback here when I ask questions. It's like, okay, does that make sense? So let me know if it doesn't. In any case, I'm going to now sub this into here. Okay, so that would imply d dx of 3 times this to the 1/2 power, of course, of 1/2 sine 8x to the 1/2 power. Now it's a basic derivative. That would be what? Chain rule. 3/2 times the parentheses to the now negative 1/2 times the derivative of the parentheses. The derivative of the parentheses would be 1/2. Derivative of sine is cos of the angle, 8x, times, of course, the derivative of the angle, which is 8. Okay, well, half, this is all times, half of 8 is 4. And I can multiply that by this guy here. 4 times 3 is 12 divided by 2 is 6. Okay, so that's 6 times, no, times 1/2. That's inside, I can't bring that guy up because the 1/2 power. Times cos 8x. Okay, so that would give me 6 stays on top, the cos 8x stays on top, so 6 cos 8x all over, I can rewrite that as a square root. The square root of 1/2 sine 8x. Okay. Now this can be simplified. I can bring that 1/2 out and under a radical and say square root of 1/2 times the square root of sine 8x. Square root of 1 is of course 1, and that's over the square root of 2, which means I could basically put this whole thing root sine 8x all over root 2 and then rationalize it. If I wished to do so, I could do that. There's ways to simplify it down, but that's the basic, that's the calculus behind it. Okie doke, guys. All right, I'm over time and I must get going at this point. So I hope this helped out. If anybody has any other questions, just send me an email on it, and I'm going to save this and render the video and get it uploaded to Canvas so that you can go back and look at some of these problems if it does help. Okay,
Can
guys.
you go back to your work on number 12 and I'll just like take a picture of it with my phone?
Yeah, I can do that real quick. Let's see. I don't know if I have it number. Which one was number 12?
It was the piece price
P
and
problem?
cost one.
Yeah. Yeah, that one. There you go. Can you see it?
Yeah. Thank you.
Sure. Alrighty, guys. I think that's a wrap then. I have to get going. So if you have any other questions, send me an email, maybe tomorrow before I can answer it. But have a good evening.
Thank you.
All right,
Thank
you're
you.
welcome. You're very welcome. Take care, guys.